Welcome to Solving Exponential Equations. Today we're going to focus on the exponential equations where we need to create a quadratic in order to solve. When we solve exponential equations, lots of times we're solving for that exponent and we need to use logs, or maybe we have a common base or something like that. But these look a little different, okay? And so with these, we're gonna need to kind of look at it and use some substitution in order to make it look like a quadratic to help us solve. So let's get started. So when you first look at this, you might be like, what? How do I do this, right? Like, can I just guess at numbers? I mean, yeah, we could guess all day, right? And sometimes maybe we could get it right and sometimes not, right? But right here, I'm seeing that something has a 2x and then an x, right? I want you to start looking at it like this. If 2 to the x were there, I could actually write that as being squared, right? Because that would be 2 to the 2x. 2 to the x all squared, because remember you multiply the exponents, minus 2 to the x, which there's technically a 1 in front of there. And I'm also going to go ahead and move over my 56 to set it equal to 0. So now it actually looks kind of like a quadratic. And if you don't believe me, watch this step. I'm going to go ahead and look at my 2 to the x, and I'm going to say, you know what, 2 to the x, I'm going to replace with my favorite variable, m. So I have m squared minus 1m minus 56. Wait a minute, you've seen something like this before. Yeah, of course. What multiplies to negative 56 and adds to negative 1? Let's go ahead and factor. And we know that it has to be an 8 and a 7, where our 8 is negative, so m minus 8. M plus 7. So m is going to be 8 and m is going to be negative 7. Okay, but now I'm not through, because that's great, you solved for m, but I'm trying to solve for my variable x. So I need to go ahead and create two other equations here, and I'm going to replace the m with what we originally replaced it with. So 2 to the x equals 8. And 2 to the x equals negative 7. Now, this is actually a really nice one. If you look at the lesson where we went ahead and solved using common bases, or maybe you can just kind of see that 2 to the what gives you 8. So 2 to the x equals 2 to the third. So we can see x equals 3. Great. Now I come over here and I think, 2 to the x equals negative 7. Well, I don't know that. I could put it in log form. So log base 2 of negative 7 equals x. Ooh, this is a problem, isn't it? If we think about the domain of log, everything that goes inside the log needs to be greater than 0. So this is obviously not greater than 0. So this is actually not possible. So this is one of those extraneous solutions. It's not possible. I can't solve for x. It's not even a solution, really. I just can't go any further with it. And so right here, x can only equal 3. All right, let's look at some other ones that look a little different, but we're still using that same quadratic properties. So right here, I have 3 to the 2x plus 3 to the x plus 1. What? There's an x plus 1? Yeah, we'll look at it a little differently. So again, because I see this 2x, I'm automatically going to start thinking I need a quadratic. So 3 to the x, I'm going to rewrite it again like so, because that's the same thing as 3 to the 2x. But then remember here, if you are adding exponents, that means originally the bases were being multiplied. So right here, 3 to the x times 3 to the first is 3 to the x plus 1. I'm going to rewrite it with the 3 in front and then the 3 to the x over here, just so it looks more like a quadratic, right, where I have my coefficient. And then I'm going to move over the 4 and to equal that 0. So again, I'm going to replace 3 to the x now with my favorite variable, m. So I have m squared plus 3m minus 4 equals 0. Again, we can go ahead and factor what multiplies to negative 4 and adds to 3. Well, that must be 4 and 1, but obviously the negative 1. So m plus 4, m minus 1. M equals negative 4, and m equals 1. But remember, you are not through, because m is not what we're looking for. We're looking for x. So I can set up 3 to the x equals negative 4 and 3 to the x equals 1. Over here, we talked about this in the last example. If I try to use log on this, I have log base 3 of negative 4 equals x. That's not greater than 0. Cannot do that. Meh. Okay. Over here, 3 to the what equals 1? Well, you probably are already thinking, that's 0. It is 0, right? Because anything to the 0 power is 1. If you also just want to verify that, log base 3 of 1 equals x. Log base anything of 1 is 0. So x must be 0 for these. For the last one, we didn't go ahead and plug it in, but I do want to plug this in just to show you how this works. So really, this is 3 to the 0, because it's 2x, right? Plus 3 to the 1 gives us 4. Well, that makes sense, because 1 plus 3 equals 4. So in fact, our solution does work. Whoa, this one looks a little different because I have a base of 2 and I have a base of 4. Ha, sneaky. We know that 4 can be rewritten, so let's do it. So I have 2 squared, really, to the x. That's not really the way I want to write it for a quadratic, though. So I'm going to rewrite it as 2 to the x, quantity squared. And then we talked about this. Remember, this is 2 to the x times 2 to the third. That looks like a wonky 2 there. Again, I'm going to rewrite it as 2 to the third and then as 2 to the x here. Again, you're seeing why we want to go ahead and get the same base and have that 2 to the x in the parentheses there, because now we can substitute it again with another variable, my favorite variable. Remember, 2 to the third is 8, so 8m plus 15 equals 0. So again, I kind of like to make a little note to myself. M is 2 to the x, that's how I replaced it. What multiplies to 15 adds to -8. We have m minus 3, m minus 5, and there we go. Now, our last step, we still have to go through 2 to the x. Oh, well, I'm jumping ahead of myself, not the last step. M must equal 3, and m must equal 5. Now, we're going on the last step and replacing that m. So 2 to the x equals 3. 2 to the x equals 5. Well, I don't have any negatives, that's great, but these are also not very nice with common bases or anything like that. So I am going to need to use logs here. So log base 2 of 3 equals x, and without a calculator, my friends, that is all you have to write. It's log base 2 of 3, done. Over here, log base 2 of 5 equals x. And again, without a calculator, that's all you have. And we have 2 solutions now. Fantastic.